This is one of your TA's set, review sets. Should be everyone has access to it by the end of your discussion. So the first thing you can do is to count how many carbon that was the same. Oh, did I write the question wrong or not?
Yeah, I think
Oh,
the
oh.
top is supposed to be an ester. Or an ether.
Okay.
It's just beside that one.
Also.
And then it's the same.
Okay. This is when you use retrosynthesis. Okay, didn't people confuse on retrosynthesis? Okay. One step back. Okay. So. Can people see this? 1, 2, 3, 4. Can people see this? I said see this means can you see how it was break out? And this need to be see it.
Basic conditions.
I think she made the same side, right? She made it the same.
Oh, right.
Yeah, so either would work. Yeah, doesn't matter. But the nucleophile, if you use if you use basic, actually in this case, I don't know what's on her answer, but since this side is still a little bit bulkier, if you use basic, it turns to go this side because base always do the less steric hindrance test. I know it's a primary here, but don't you have more things going on here? Not sure what's on her answer, but if I were, I will use. Yeah. It's just for save, okay? Okay, and then if people are good with that one, how to form here? So I know she used MCPBA to form this, which I'm so sorry. But okay, I said we can do something else.
I don't even know how you could do it without MCPBA because of like how would you get like an OH group on that second one? Because that's like my confusion. Is like it's like it just kind of pops up. Like,
Okay, wait, question. You have the H, you just wrote H plus. Are you saying that
H3O.
can I put in NaOH with it?
If you put NaOH with it,
I mean, technically,
you should
if you just care
CH3ONA.
about the end product and not you, you could do that.
So it
because
has to have,
some
like,
of them
some
won't
sort
have
of,
the
like-
hydrogen.
Yeah. So if you want to use acidic H3O plus, if you want to do the basic condition,
Like H minus?
no, don't do H minus. You use this one, and then the solvent should be. Didn't you say this all the time in your? Yeah, you should use the one that we.
That one?
Yeah.
Professor, if we can't have an optimal solution here, can we substitute the Cl with this, with an ROH, and then like do SN1 and just like know the fact that the hydro shift is gonna happen, but like still take it because some of them won't have the hydro
if you
shift.
try to substitute with the ROH, it's gonna move to the tertiary.
Yeah.
That's the problem. You can't.
Yeah.
You said in class that it doesn't do that for all of them, so there'll still be some.
Some
amount
of them.
that
Unless you do
for which it won't
CH3.
move.
Okay, let's say if you have this, then how if
No,
you.
but I'm saying not with just an OH, like to get it so that it would just be that ether.
Get to be that
So
ether.
you could have like a CH3 CH2OH.
You can't do that. It will shift
That's an ROH.
the tertiary because it's one.
So
Right.
I see what you're saying. You want to say you think some of them is going to shift here. You cannot do that for synthesis.
That's because the yield is just so incredibly small.
That's
Yeah.
I mean, I knew that the yield was going to be tiny. Like I know that there's the hydro shift, but I mean, I'm saying if we don't have anything else that we can do.
Okay.
I don't even know what MCPBA is.
Makes an alkene.
Okay. So this one, really the case is to use MCPBA because we don't have a, the previous one is CL. The only way that you can use WES is this one is an OH. So far, you haven't learned any way to add an OH on here. The only way we have teach you, oxygen is already here. So the only way in your, so that's the, you need to use MCPBA. Yeah.
So something like that won't be on the exam.
This won't. Something I want to say after I